Hi everyone, I'm going to take a look at another problem from section 4.4, logarithmic properties. So this particular problem that we're looking at is 3 times e raised to the 900ths times t equaling e raised to the 1400ths times t. So what I want you to notice here is the fact that our variable is not only stuck up in the exponential position, but it's also located in two different places. So my goal right now is to get t into one spot before I can actually solve for it. So what I think I'm going to do here is I'm going to divide both sides by e raised to the 900ths t. And the reason why I do that is, first off, as you can see, I did cancel out the e raised to the 900ths times t on the left-hand side. And that's going to leave me with 3 is equal to, and in order to clean up this right-hand side, notice that I can use my exponential rules here. I do have the same base coming through, so both of the values that I'm dividing have a base of e. So that means that I can kind of quickly do an aside here, and I'm going to note that I can take the, keep doing that. I can take the exponent on top and subtract it with the exponent on the bottom. So this means that I'm going to have 3 is equal to e raised to the 500ths t. At this point, we're actually in more of an advantageous position. So what we can go ahead and do here is, you could use your swoop method. So method 1 would be to do as follows. We would take our step that we have above, and we could go ahead and do our swoop method. Go this way. Let me erase that out of the way. Okay. So then this is going to tell me that I'm going to have the log base e of 3 is equal to 500ths times t, which then would allow me to divide both sides by the 500ths. So your final solution can look one of two ways here. So we could keep this as the log base e of 3 divided by 500ths. Or another way that we could write this, let me scoot this up so we can see, is instead of writing it as the log base e, we could just say the natural log of 3. So I can just change the notation that I'm using here. So the natural log of 3 divided by 500ths is equal to t. And I'm okay with you leaving your solution like that, because if you were to actually hop onto your calculator and figure out the natural log of 3 and then divide it by 500ths, you're going to get a nasty, kind of irrational, non-terminating decimal. So in this way, everything's kind of neatly tied up. So let's take a look at another method. Let's take a look at method 2. And I will show you that you're going to get the same result. So again, starting with that same line that we have right up at the top of the screen here, what I'm going to go ahead and do is I'm going to take notice and say that I have an exponent with a base of e right here. Okay? So that means I need to figure out how to undo it in order to clear it. Okay? That would, in order to clear the base of that exponent, that would mean that the value that I have sitting in the exponent can come down, and then I can work with it. So what I'm going to go ahead and do then is I'm going to take the natural log on both sides. The reason that I'm going to do this is because the natural log has a base of e, and then my exponent has a base of e, which would allow me to clear them out. If you need a refresher, please recall that we have an identity rule that says the log base b of b raised to the x is just equal to x, because these two items will cancel each other out, because they have the same base and they're inverses of each other. So, at this stage then, I have the natural log of 3 is equal to 5/100ths t. And what I want you to note here is that I actually have the same step as I do over there. The notation is the only thing that is different. Okay. So we'll go ahead and we'll finish this up. We'll divide both sides by 5/100ths. And this is going to leave me with the natural log of 3 divided by 5/100ths is equal to t, which, as you can see, is going to give me the same result as in method 1. So I hope that this was helpful. If you do have any other questions, please let me know.